Thank you for tuning in and welcome to the final episode of AzureTalks of this year. My name is Rolf Schutten.
My name is Smorenburg.
And today we are covering our Festive Tech Calendar contribution of this year called Jingle Ops, a merry GitOps carol with Flux and Terraform Controller. And this year, Festive Tech Calendar is raising money for the Raspberry Pi Foundation, which gives young people access to free computing education. And if you'd like to contribute, please visit the festivetechcalendar.com website. For every £20, which is about 23 euros or 25 American dollars, the foundation supports 60 young learners to get creative with online coding projects. And having that said, Robin, let's dive into today's content. Let's first cover some basics and definitions here, because GitOps is a term that might get misinterpreted in our field or our area of work. And do you mind starting explaining what GitOps is and what it isn't?
Yeah, sure. Let's pull up my screen.
All right.
All right.
What is GitOps?
Yeah, so there we go. So this is the open GitOps page, right? So they're tasked with making sure that all the GitOps principles are clear and that there's like this common understanding. So yeah, let's start it. Let's get started by answering the question: what is open GitOps? All right. So I'm just gonna narrate this, and then we scroll down to the page, but. Open GitOps is a set of open source standards, best practices, and community-focused education to help organizations adopt a structured, standardized approach to implementing GitOps. And then you're still wondering, okay, what is GitOps then, right? Because structured and standardized approach is nice, but then, okay, what will GitOps give us on top of what we already have? Right, so if we look at the GitOps principles, this is the first version. So the first principle is declarative, right? So you express your desired state declaratively. So you basically tell or you describe what you want, and then you tell the system to like, hey, this is what I want, make it so, right? So that's declarative. Terraform, for example, is a declarative tool. Then the second principle is versioned and immutable. So that means that your desired state, so your configuration files, your declarative configuration files, which define your desired state, are stored in a way that enforces immutability, versioning, and retains a complete version history. Well, usually that's going to be Git, right? So GitOps, GitHub, or Azure DevOps repositories, or what do we have? Bitbucket or GitLab or any tool that supports versioning. And then the third principle, pulled automatically. So there's like a software agent running in your cluster, which today is going to be Flux, which is monitoring your Git repository. So your store basically, or your source. And then, I will pull in that configuration and then make sure that that configuration is applied to the cluster and in our case today to your application as well, because that's where the Terraform controller comes in. And then the fourth principle is continuously reconciled. So if you look at Kubernetes, you have these reconciliation loops, right? So every now and then this loop runs, and then Kubernetes checks if all the things in the cluster are still configured the way that you define them, right? The way that they're stored in your etcd database. So, and that's where GitOps comes in as well. So then you basically extend that reconciliation functionality or the reconciliation loop towards your source repository, which contains your complete cluster and application configuration.
So it already triggers me in terms of a lot of people think GitOps is just a set of tools. But obviously it's not. But it does cross my mind that some tools are not GitOps compliant, let's say. So if we're looking at just plain scripting, fire and forget scripting, that's not GitOps, right?
No, that's true. And scripting is usually also not declarative, right? It is imperative. So
Right.
you basically define the steps that the system needs to go through to reach a certain configuration or a certain state.
Mhm.
Right. So the difference between imperative and declarative means, okay, imperative, you define all the steps to reach a certain destination or a certain configuration. And then you have declarative, where you basically just define the end result. So I want this. And then the system usually figures out how to achieve that. Right.
Right. So that sounds like it's very compliant, working together as well with DevOps practices and agile methodologies, right? So having the end state in mind,
Mhm.
getting your system being managed by a declarative approach. And I also see pulled based instead of push based, right? So
Mhm.
we have push based and pull based
Mhm.
automations. Um, maybe it's good to declare the difference between those as well, right?
Yeah, of course. Of course. So, push pull, yeah, right. Usually it's on the door, and if you push while you need to pull, then the door won't open, and the other way around, right? So, but push means you're pushing your configuration towards the cluster. So in a Kubernetes, right? Let's just assume Kubernetes in this case, right? GitOps is centered around Kubernetes and cloud native. Of course, we can have a conversation about, is that completely exclusive? No, there are some other scenarios that you can include, but let's not go there. So Kubernetes push means, okay, I do kubectl apply manifest or kubectl create, right? So I basically push the configuration towards the cluster. GitOps talks about pull. So you have that agent that is running in your cluster, and that pulls in the configuration instead of you pushing the configuration. Because another way of achieving this is, okay, I have a GitHub action or an Azure DevOps job, right, that connects to my cluster and applies certain configuration and certain manifest files. That's a push approach, right? If you have Flux in our case today, that is monitoring and eventually pulling in that configuration and then applying it. Right, so that's basically push versus pull.
Awesome. So I already think of business continuity scenarios and security and compliance scenarios where this pooled based declarative approach may come in very handy. But there are obviously some pitfalls which you will which we will walk through today, right, Robin? Because you have you
Mhm.
had some fun with it last days to prepare this session.
Uh-huh.
Um,
We
and
had some fun. Yeah.
yeah, we had some fun indeed. Oh, me more on the application side, but we will talk about that later, right? So, um, anyhow, um, you mentioned the agent and you mentioned Flux,
Mhm.
which is like maybe the main player in the demo today that we're showing today.
Mhm.
Obviously, we also have the Terraform controller. Let's just briefly explain what Flux is and what the Terraform controller does, and then just dive into the demo.
Yeah. Yeah. Sure. So, Flux is that software agent that runs in your cluster, which will monitor sources that you configure. Well, today that's going to be a GitHub repository. And based on on the information that's in that repository and the way it's structured, and it uses customize as well. So we'll take a brief look at that. I will go ahead and configure your infrastructure, so your cluster or what happens in your cluster. So today we'll be deploying the Terraform controller, because the Terraform controller is a separate controller that you need to install, so it's not pre-packaged with Flux. And then we'll deploy the Nginx ingress controller, because we want to handle some ingress towards our application. And the other one that we'll be deploying is the cert manager, because of course we want to make sure that our application is reachable over HTTPS and has a valid certificate. Right? And ideally we don't manage that ourselves, so we use cert manager for that. And then the Terraform controller specifically enables you to use Flux and the whole, all these principles, right? Declarative, versioned and immutable, pulled automatically, and continuously reconcile. but also for your infrastructure. So then Flux looks at, or the Terraform controller looks at the Terraform code that resides in that repository or in one of the configured sources, and then goes ahead and run basically run Terraform plan, run Terraform apply for you from within the Kubernetes cluster. So this way, you can enable teams to define their infrastructure in Terraform code, submit it together with their application code, and also using Terraform to define your Kubernetes manifest files. If you look at Flux and the Terraform controller, Flux is that software agent that runs in your cluster that is monitoring sources, right, or Helm repositories or whatever. So you have multiple things that you can configure. Flux comes with like 4 built-in controllers. You can enable more controllers, but more on that later. So, and then you can install the Terraform controller as well. So it's not a default controller built in Flux, but it's like an extension. You can install that, and that enables you to basically include Terraform code in your repository or in one of your sources as well. And then Flux will look at that. The Terraform controller will look at that, and then it will start provisioning infrastructure for you. So what you see with cloud native applications is that you don't want to run everything in your cluster, right? So your data store or your database. Today's example is going to be a Redis, Azure Cache for Redis. So it's going to be a Redis instance. Right, so you can deploy that with your containerized application on top of Kubernetes. So then you have your app, your database running next to each other inside of the same cluster. There are ways of managing, data or state in your cluster, but ideally you deploy that outside of your cluster. So you need some infrastructure. Well, if you're running on Azure, then you can create like a platform as a service offering or something else, right? Or you need maybe a storage account or whatever you might need to support your application. So you don't have to have different workflows. You can basically define your app using Terraform or define your app's infrastructure using Terraform. But then you can also define your Kubernetes manifest files that you need for your namespace and your deployment using Terraform as well. So then you use one tool to define both, right? Because there is an official Terraform provider, an official Terraform Kubernetes provider that you then can use as well. And then if you, for example, deploy a database, then you can use the output of that database, for example, a connection string, and use that as input for your manifest file that's also defined in Terraform. Right? So you don't need any additional tooling to pipe that information or that output towards input in another tool, and etc. You just use Terraform, which works pretty well. Of course, we'll demo that. But yeah, these are the 2 components that we're primarily using. Let me switch to my screen. So we're in the Azure portal, right? In case you didn't notice. But let's go to resource groups. And let's look at everything that relates to Jingle in this case. Jingle, remove the noise. There we go. So we have a resource group that just, contains the Terraform state. I usually do that in a separate resource group because otherwise you're trying to deploy a resource group while you don't have a state yet and stuff like that. So I use a script to deploy this because, otherwise, hen-egg problem. Then I deploy like a environment independent resource group. I usually call that shared resource group with shared resources across certain environments. So what this one contains, for example, is a container registry, a shared key vault in case you have certain secrets or certificates that you use across your different environments. Environments in this case are development, staging, production, etc. Right? A central log analytics workspace, because otherwise you end up with all these different log analytics workspaces. Usually you don't want that.
No, you don't.
No. So I've, in this case, 2 public IP addresses that are already created. So I have one for production and one for staging. Both are destined for the Nginx Ingress controller. And I do this on purpose because usually within organizations, it takes some time to get a DNS record or DNS change processed, right? So in case you need to redeploy your environment, sometimes that happens. Then if your public IP address is inside of that same resource group and then inside of that same deployment, then you need to recreate or redeploy that as well. And then you end up with a different public IP address, which result in DNS changes, downtime, et cetera, et cetera. So this way you already pre-create them basically, or pre-deploy them, and then later on you use them.
Makes sense. Yeah.
And then a storage account for other logs, right? So if you start to enable logging for your Kubernetes cluster and you're not very granular and know what you're doing, then it's very easy, very easily turns into like 40-50% of your running costs per month, just logging, right? So a lot of logs you just stream towards a storage account instead of a log analytics workspace, make it significantly cheaper. So that's the central component, or basically the central shared resource group, if you will. And then I already deployed, quote unquote, production environment, which is, well, in this case, environment specific, which includes a virtual network, of course, otherwise we cannot deploy our Kubernetes cluster, an NSG to control our inbound and outbound traffic, a key vault, in this case for my disk encryption set. So we're using a customer managed key for your encryption, your disk encryption. Then we have 3 managed identities, one for AKS, which is assigned to the node pools, one for the disk encryption set because you need it, and one for the Terraform controller. So the Terraform controller has its own identity, which will be tying using workload identity and workload identity federation, if that's the right term, to a service account, to a TF runner Terraform controller service account. So this way that service account can authenticate and basically deploy a resource group and the supporting resources in a subscription, right? Because if you deploy resources outside of your cluster, well, that specific agent needs to be able to authenticate and authorize through Azure, right?
Makes sense. And it's, I think, a good practice for segregation of duty and following least privilege practices, right?
Oh, yeah, absolutely. All right, so before we start deploying, let's briefly look at the repository structure. Like I mentioned before, Flux is looking at a Git repository, in this case, a repository or repo in GitHub. Right, and the repository is structured in this way. So you have an apps folder in the root with a base, production, and staging, an infrastructure folder with the same subfolders, and a cluster folder with production and staging in there. When you bootstrap Flux, because that's the term, then you define what cluster folder to look at. So we will bootstrap Flux for the production cluster folder. So you define that when you bootstrap it. And then it will use the information in that specific folder to figure out what to use from the infrastructure, what to use from the apps, and etc. Then it will be using customize. So that's a way of patching certain configurations, right? So if we look at this base here, then this is a deployment manifest file for an LDAP application, right? And it has a staging and a production patch. So in case of a staging environment, you create 2 replicas. And in case of a production environment, instead of 2, you create 6 replicas, right? And maybe some other information. So this way you can have a slightly different configuration for each and every environment, right? Even though environments usually need to be the same, there are slight deviations needed here and there, right? So then the infrastructure that I just showed in the Azure portal is in the Jingle Ops GitHub repo on my profile. So this basically contains all the Terraform code for the environment, right? So and for the shared resource group as well. So the shared components and the environment specific components, and the script to create the storage account for your Terraform state, right? And here we have the Jingle Ops source repository, right? Which mirrors this structure. Right, apps, clusters, infrastructure. Now, if we look in apps, then we have base, production, staging, clusters, production, staging, and infrastructure. Base, production, staging. All right, so if we look in clusters, production, in this case, we have app configuration or an app customization, actually, which looks at apps production, right? And then we have an infrastructure customization or two for the infra controllers, which in this case, because this is the production cluster, right?
Mm-hmm.
It looks at the path infrastructure production controllers, right? And for the configs, we'll get into that later because there are some dependencies. We look at infrastructure production configs, right? If we look at staging and we look at the infrastructure, then you basically see the same thing, but in this case, it looks at the staging folder and the staging folder here. So this way you can basically segregate or split up configurations across environments using specific folders.
Makes sense. Yeah.
Yeah. When you have the time and you're very interested in this, first look at this docs page, right? The Flux cd.io documentation. And the first one in guides is ways of structuring repositories. So if you read this, then you better understand like, oh, it's set up this way because of these reasons. And there are other ways of doing it, right? Repo per environment, repo per team, etc. But yeah, for today's demo, we go for the first one, the mono repo. All right. So before we can get started, let's go to my IntelliJ. Let's go back to the portal first. And let's grab the object ID of my managed identity for the Terraform controller. So that is the client ID. Let's go to the JingleOps source repo, and let's change this here and there because, of course, it needs to be aware of the client ID to use for the authentication. All right, so if I go to infrastructure, production, controllers, Terraform controller, then there's a Azure workload identity client ID. Let's swap this out. And then we have another one here for the app that we're going to be deploying today. So that's the first step. And that's it. Is this, for example, if you look at the Ingress rule host variable that we'll be using for the Terraform deployment, then you notice an IP address here, which corresponds with the public IP address in the shared resource group. Right? Mm-hmm. So you need to, after you deployed your main infrastructure, in this case, the Kubernetes cluster and all the supporting resources, before you bootstrap Flux, it's important to change out a couple of things, right? Because the client ID is only known after deploying the managed identity, right? And the same goes for that IP address. In this case, it was already known because we pre-deployed that. Okay, let's save this. Let's commit this. Let's use AI to generate my commit message. And then just commit it anyway. There we go. So that resulted in a new commit in our source repo. See now, so we swapped out the client ID and production configs for both the apps and the infrastructure. Let's bootstrap Flux. So let's go here. Let's copy this. Let's paste that in. And there we go. So I already connected to our AKS cluster. So my kube context is already pointing to my AKS cluster. And now I'm bootstrapping Flux. So it will go into the cluster. It will deploy all the Flux components. It will set up the source in this way, in this case, pointing to the GitHub repository with my last name as owner, because that's my profile, the repository name, branch, in this case, main, path, clusters, production. So here it goes into the clusters folder and then into the clusters, into the production folder. It's a personal profile, so it's not an organizational or organization profile, and it's not a private repo, so it's a public repo. All right, all components are installed and are healthy. So let's go to Lens. Open the cluster up. Oh, that's interesting. Let's try it again. There we go. Let's go back to the overview pods. Let's refresh this in case it's not refreshed, and let's sort this on age basis. So it started already installing all the underlying or all the controllers defined in the repo, right? So it starts with the Helm, the customized Helm source and notification controller, which are all Flux controllers. Then it installs the Terraform controller in the Flux namespace as well. Then it installs the cert manager in the cert manager namespace, right? Nginx in the Ingress Nginx namespace. But yeah, the Weave GitOps, which is the dashboard. Let's look at the dashboard while this is all deploying. All right, so let's go to services, Weave GitOps. Let's remove this. Let's forward this again. Okay, there we go. Okay, so it basically Flux went in and deployed, reconciled, and took care of all the all the deployments and configurations. All right, if we look at apps in this case, we see the app, which is the voting app, which is now currently in the Terraform planning stage. All right, so if we go back to the cluster and we go to pods, then we'll see a vote TF runner pod here. If I open this up, then you basically see what you normally would see if you do a Terraform deployment, right? So I did the Terraform plan, and then it starts a new runner, and then it's going to be doing a Terraform apply. So it created a namespace. It created a random ID for my Redis cache. Then it created an Ingress resource, a service resource, then a resource group, and now it's deploying a Redis cache, which can take like 20 minutes. Right. So while this is being deployed, let's look at the Terraform code, so you have a better understanding. Okay, what's happening then? Because we're deploying a vote app, but what's the underlying code, and why are we deploying a vote app and not our custom Santa app that we've been developing? Right? All right, let's look at the Terraform code, and then let's discuss the app in more details. So in the Jingle Ops source GitHub repo, we have the apps directory, right? And then we have the production directory, which in this case is being used to deploy the app. And it has a couple of production specific configurations going on. So we have an environment, which in this case is called production. We have a container image because you want to be able to deviate, to deploy different container image to staging versus production, right? You want to have that possibility. So if you look at it here, then we have the same configuration, but then staging specific, right? Environment staging. Of course, in this case, we're using the same container image. But the Ingress rule host and the IP addresses differ already. You're going to have a different client ID as well, maybe even have a different subscription ID, depending on, if you segregate or how do you say, what's the right term? Use different subscriptions for each and every environment, right? But then in the base, we have the vote folder, which in this case contains Terraform code. And if we look at vote.yaml here, this is a Terraform resource. Right, so it's using the Flux CD.io API version and a kind of Terraform. So this is a Terraform resource in Kubernetes with a name and a namespace. But then it will you basically specify like, hey, you can find the Terraform code in apps base vote Terraform, which is this folder, right? And then here you also say, okay, the runner pod. So that's basically the pod that is currently doing the Terraform deployment here, this one. TF runner, which we're looking at the logs here, is using a workload identity to be able to authenticate to your Azure subscription to be able to actually do that deployment of your infrastructure, right? And then we have the Terraform code. So, define the providers using the Azure RM, the random, and the Kubernetes provider. Okay, some provider features. Okay, the data for the Azure client config. So we're using we're able to use the current client config data in our Terraform code. Some locals where I set the location abbreviation, the environment abbreviation, and then basically construct a name suffix. Random ID for the Redis cache. Resource group, right, where we're using the local suffix that I created here. Then the Redis cache itself, right? Then the Kubernetes namespace. So you're using the Kubernetes namespace v1 resource to basically define or to create or deploy your Kubernetes namespace. Then the Kubernetes deployment, right? So replicas, selectors, then the template, then the template spec. And then here you find the container image variable, the app name variable, the container port that's exposed. And then this is where some Terraform magic comes in, right? So there's the vote app looks at a Redis environment variable where it expects the Redis hostname, right? And if there's authentication in place for your Redis cache, which is the case, then it also expects the Redis password environment variable to be present, containing the access key in this case. So this is output from the Redis cache, right? Azure RM Redis cache default, which is this one, right? Azure Redis cache default. So it will create the Redis cache resource, and then you can basically leverage the output of that resource as input into your manifest file. So I don't have to store any secrets. I don't need to use a key vault. I don't risk committing any secrets to my repo and so on and so forth.
And so let's circle back at the beginning. This is actually what you want, why you want a declarative approach, right? Instead of an imperative approach.
Exactly. Of course, another way of doing this would be, okay, I have some Terraform code that will just create my Redis cache. And then I have some additional YAML files, Kubernetes manifest files that I use to create my deployment, for example. But then I need to somehow get that output from Terraform to input for that manifest file, right? Which is still possible. You can script it. There's some other tools, but yeah, why not just use Terraform for it?
True.
All right, let's see what the deployment is doing. All right, okay. So the deployment is still ongoing. Let's take a look at the Azure portal. Let's go to resource groups. There we have an RG vote prod resource group with the Azure cache for Redis that is currently being created, right? Status creating. So yeah, we still need to wait on that. Circle back to our code and let's look at the rest of the Terraform code, right? So we have a Kubernetes service that we define as using Terraform. And then we also have the ingress resource, which we'll use cert manager because we have that installed and we have the annotation in place and TLS block configured. Oh, all right, and then it will just it will open it up. We can use it or we can access the app using the ingress rule host variable that we have configured here. Right. So this way you have some Kubernetes manifest files use customize to create some environment specific logic and to make sure that you have that possibility to fine tune certain settings. And the Terraform code.
Awesome. Let's just fast forward towards when the Redis cache is finished deploying and pick it up from there and demonstrate that it actually works the way you designed it and built it.
All right, so our Azure cache for Redis has been successfully deployed. All right, so if we open the resource, then we can see that its status is now running. So if we go back to Lens and we look at the last pod that has been deployed, that's the vote pod in the vote namespace. All right, so this is basically our application pod, which is using the Redis cache. So if we open this pod and we look at the environment variables, then we can see the hostname, right, and the key, right. cache will be gone after you look at this recording. So good luck with the key. All right, so if we look at the Terraform code, then this is these are the environment variables that we're currently looking at here. So these two are these two. And because we're using output from the Azure Redis cache as input for the deployment, then it can only start creating a deployment after the cache has been created, right? That's the implicit dependency, right, in Terraform terminology. So this way, Terraform knows, like, okay, I need to deploy the cache first, and after I deploy the cache, then I have the information that I need to be able to deploy the deployment, to create the deployment, right? So let's go back to Lens. Let's close this. Let's go to ingresses. And then we have the vote ingress, right? Which is this one, basically. And here we have a rule. So let's click on this one. And there we go. So this is the Azure. Yeah, cats and dogs. Let's give dogs a head start here. But right, so, and you also see that if if we go here and we evict that pod, I would say, okay, it's nice. Give us a new one, right? All right. Sometimes you need to refresh. There we go. All right, so it's terminating this pod. It's creating a new pod. And at the same time, the Terraform runner from the Terraform controller is running another check, right? So that's the reconciliation loop where every now and then, I think the interval is 1 minute. So every minute, it will start up the runner. It will look at your Terraform code. It will do a Terraform plan. And then, it will basically correct any deviations if there are any, right? So this way, the infrastructure is always configured the way you defined it, or you declared it, basically, right?
So this is the pool-based approach, right?
Yes.
Yeah.
Okay, so we have that one. The Terraform runner is done. We have this container now. So let's go back to ingresses. Let's close this because I've refreshed and it's going to add another vote. Let's click on this, and there we go, right? So you see that the state is not in the container itself. It's in the Redis cache, right? So, and if you deploy this without including the Redis container and you get rid of the Redis container, then your cache is gone as well.
Right, makes sense.
Let's add some more votes. But we're using Let's Encrypt for this. Let's look at it. No, here we go. So it's a Let's Encrypt certificate that's been assigned to this common name, vote.ipaddress.nip.io. That's it.
Awesome. Thank you for the demonstration, Robin. So are there any key takeaways that you want to mention before we wrap this one up and wish everyone a very nice New Year's Eve?
Oh, well, I was able to look back on the last year for the last couple of days. I'm on holiday. Well, obviously I'm still doing things, but so no, I want to thank everyone for 2023. Everyone that I collaborated with, the whole community, everyone that basically enabled me to do what I do, right? So that includes my employer, NordCloud, includes my fiance, Ronak, Bobby, even my dog right now. So, it's been an amazing year. I'm looking forward to 2024. I'll be picking up live streaming. I will be preparing some sessions. I will go into some user groups. I'm looking forward to the MVP summit in March. Yeah. So I'm really looking forward to meet some fellow MVPs in person in Redmond. So amazing 2023. Really excited about 2024.
Awesome. And I can only comply with that. So I'm very thankful that you are joining me for AzureTalks for 2024 and beyond. And I do hope to get to travel to Redmond as well for MVP Summit. Looking forward to that as well. I will be doing some public speaking opportunities again in 2024. I'm already preparing some things with Steve Buchanan, but
Nice.
more about that later. And obviously, we will try to do some more things for our community. Having that said, and being thankful for 2023, I hope everyone that watched and listened to us in 2023 will continue to do so in 2024. Robin, thank you.
Thank you.
All the best wishes for 2024. Enjoy your New Year's Eve. And to all the listeners, have a great and wonderful and healthy 2024.
All right. Later.